Hey! For almost a year now, I have been creating these colorful, satisfying simulations that are reaching millions of views across all social media platforms. During this time, a few of you have asked how I created them. Yeah, actually, a lot of you have been asking, so let's break down the whole process of creating these simulations. I have picked 3 interesting ideas that you suggested in the comments, and I'll try to recreate them. Make one that goes with the song of your choice and actually follows the beat. So here's the plan. We will create this 2D simulation of a ball bouncing inside a circle. Inside this circle, we will spawn points. When the ball passes through them, it will play a note from a song. That's it. We will figure out the details while creating this simulation, so let's get started. We will be working with the Python programming language, specifically with the Pygame library. We are starting with just a blank canvas, importing some libraries, initializing Pygame modules, creating the window for the simulation, and finally, entering the main loop. This loop will be updating our simulation. Each iteration through this loop represents one frame of the simulation. Currently, we are just filling the entire window with black, so this is what our simulation looks like. Yeah, not much going on. So let's create our border and ball. We just need to define their parameters and then draw them directly onto the screen. Amazing, but there is not much movement yet, we need to introduce physics. So we create a variable for gravity strength and 2 variables for ball acceleration and velocity, both represented as vectors. Now, with each iteration of the main loop, we need to update the position of the ball based on its current velocity and acceleration. Okay, the ball is falling, but sadly it's not bouncing. So let's focus on collisions. Firstly, we need to calculate the distance between the ball and the center of the border. Then, we need to check if this distance is greater than or equal to the border radius minus the ball radius. Simply put, if the ball is outside the border, or directly touching it, we have a collision. So, when the ball collides with the border, we first calculate the normal vector by finding the direction from the center of the screen to the ball's position. Then, we reflect the ball's velocity across this normal vector to simulate the bounce. Finally, we adjust the ball's position to ensure it remains just inside the border, preventing it from crossing the boundary. And just like that, our simulation of a bouncing ball is working. Now, we need to figure out the music part. So, we need to spawn those points I was talking about. Let's call them song points. We can't spawn those song points just randomly, because it would be impossible for the ball to play a specific song. Instead, we are going to first spawn this invisible ball with the same initial parameters as our original ball. This way, both balls will have the same trajectory throughout the entire simulation. After a few seconds, we will spawn our original ball. The invisible ball will spawn these song points, and our original ball will pick them up. Then, we just need to time it correctly, so that the song points play the specific song. So, we created the invisible ball just like our original ball. But we need to add a timer that will ensure the invisible ball starts moving first, and after a second and a half, the original ball will start moving too. Just like this. Okay, let's finally create those song points. We create a list to store all the information about the song points, and a function to generate new song points. Then we create a list to store all the times when a song point will be created. For now, let's fill the list with random numbers. We will also create a time index variable so we can track our current position in the list. After that, we will create a condition in the main loop that will check if it is time to create a new song point. And last but not least, we draw all the song points. Looks great, but the song points are not disappearing when the ball flies through them. So let's quickly fix that. In the main loop, we need to check if the first song point in the list is at the same position as the original ball. If it is, the song point will be removed from the list. Great, we can finally move on to the most important part, making the simulation play a song. Here is a MIDI file of a song called Rush E. We need to write down all the times in milliseconds when each tone of the song is played. It took me an entire hour to write all of this down, but it's working, so it was definitely worth it. And here are the tones that the simulation will play. Don't even ask me how long it took to split the song into 269 separate audio files. Let's load them into our simulation. First, we initialize the Pygame mixer and the number of channels we'll be using. Then we load all the audio files. And finally, we play the corresponding tone when the ball reaches one of the song points. I have added a few visual effects, and this is how our finished simulation looks. If you want to get the source code for the simulations I'm creating in this video, check out my Patreon page. All my fellow programmer patrons have free access to all source codes available in the store. Let's create the second simulation. A ball is bouncing in a circle with a small hole. The ball will bounce until it goes through the hole. And after it goes out, 2 new balls spawn. So instead of creating just one ball, we'll have to simulate a bunch of them. Similar to the previous simulation, where we used a list to store information about the song points, this program will use a list to keep track of all the balls. And of course a function to create a ball at a random position within the border, with a random color and random velocity. We can't forget to modify the main loop, so that with each iteration all the ball positions are updated and all the balls are drawn. Let's see what happens if we spawn a new ball with each border collision. They spawn exponentially, so it gets really crazy really fast. Let's turn it off before it crashes. Okay, we need to create a hole in the border. Here's how we're going to do it. We're going to create a sector of a circle that will represent the hole. Then we'll make this sector rotate around the center of the border. If the ball collides with the border within this sector, we will let the ball pass through the border. Firstly, we define the parameters of the hole and write a function that will check if the ball bounces inside that sector. Then we make the hole move by shifting its position by half a degree with each frame. And we need to draw the hole. For that, I used Pygame's draw polygon function. The hole is moving, but currently the ball can't go through it, so we need to adjust our collisions. When the ball collides with the border, we use our function to check if the collision occurred within the hole. If it did, we let the ball pass through, but if the collision occurred anywhere else, we reflect the ball's velocity just as before. Okay, now the ball can actually fall out through the hole. The last thing we need to do is remove the balls that have gone off the screen, so our list doesn't get full of balls that are not visible in the simulation. We should also spawn 2 new balls whenever one falls out. Our second simulation is working as well. If you have any interesting programming ideas you would like to see in the next video, leave them in the comments. A ball bouncing in a ring, where each bounce makes a spike appear on the inside and spawns a new ball. Ends when there are no more balls. This should be pretty easy. We just need to modify the simulation in which we simulate a bunch of balls. So as usual, we are starting by defining the parameters of the spike. Then we need to create these 2 functions. The first function calculates the position of all the points of the spike and creates the spike. The second function checks if the ball has collided with any of the spikes. Of course, we need to update the main loop, so that if the ball collides with the spike, it gets removed from the list. Additionally, if the ball collides with the border, a new ball and a new spike will spawn. And we can't forget to draw the spikes on the screen. The simulation works, but we have a small problem. The ball gets instantly removed because of the spike it created. We don't want that to happen, so let's quickly fix it. We will add a timer for each spike that ensures that for a few frames after a spike is created, it cannot remove any of the balls. Great! The third simulation is now working as well. Creating these simulations is a lot of fun. However, learning how to program them might sometimes be a bit tricky. If you want to speed up your learning process, Brilliant, the sponsor of today's video, might be something just for you. Brilliant is where you learn by doing, with thousands of interactive lessons in programming, math, data analysis and AI. Brilliant is a learning platform designed to be uniquely effective. It's not just about listening to 2-hour-long lectures and then forgetting everything. Instead, you learn interactively. Each course on Brilliant lets you engage with concepts, a method proven to be 6 times more effective than watching lecture videos. For the past week, I have spent 15 minutes each day working through this Python programming course. And now I'm sad. I'm sad because in the past I had been learning programming the hard way, doing all the research myself, and figuring everything out on my own. When all this time there was an amazing course that could have taught me everything I needed to know to start programming. So don't make the same mistake I did. Try everything Brilliant has to offer for free for a full 30 days by visiting brilliant.org/CodeCraftedPhysics or clicking the link in the description. You will be hugely supporting my work and also getting 20% off an annual premium subscription.